Good morning, everybody. We are going to be doing double angle and half angle formulas today. Our do now today is a little bit of a challenge. You're given that the cotan is equal to 2. Remember that cotan is not very friendly, but we do know that cotan is cosine alpha over sine alpha, and that's equal to 2. And again, we got another cotan, so cosine beta over cosine, or sine beta, is equal to 2/3. Okay, so neither one of those are very friendly. So imagine if we do the thing where we flip both sides of a fraction, and therefore this is now sine alpha over cosine alpha. Instead of 2 over 1, now we got 1 over 2. And remember that sine over cosine is tangent. So we got the tan of alpha equaling 1/2. Same thing, flip a rule on both of these guys. And that's 3 over 2. So therefore I also know that the tan beta is 3 over 2. Alright, so now I know tan alpha and tan beta. And they're asking us to find the cotan of alpha plus beta. So what we're going to do, we're going to use this hint over here, that we know that the cotan of some angle is nothing more than 1 over tan. So how about we continue with what we learned yesterday, and we figure out 1 over the tan of alpha plus beta. And if I figure that out, that will be the same as the cotan. Now, tan of alpha plus beta, I'm trying to use really dark markers, so I'm really running out of room. So what I'm going to do is kind of squeeze it over here. So the tan alpha plus beta, alright, we practiced that all day yesterday, is going to be tan alpha, which is 1/2, plus tan beta, which is 3 over 2, over 1 minus 1/2 times 3 over 2. Alright, I'm going to have to do a little bit of calculating here because I'm out of room. This does calculate to be 8. So if you did all of that work and stay change flipped and everything, it comes out to be 8. And that brings us back over here. If our goal was to figure out cotan alpha plus beta, well, we would have done it by doing 1 over the tan of alpha plus beta, which we figured out was 8. So we can say that this final answer will stick with 1 over 8. Alright, so our lesson today is about a whole bunch of formulas. These will be given to you, so don't worry. But these are called double angle formulas. So for instance, if you know 30 degrees, well, double 30 degrees, 60 degrees has a lot of special properties, and these are all proven as well. So what we're going to do is, let me see how pencil shows up here, because that marker's not so great. We'll call this 1, and we'll label these right down the row. I want you to do the same, because there's so many of these formulas. I want everybody to know which one we're using. 1, 2, 3, 4, 5. That's 6, 7, 8, and we'll call that our 9th formula. And again, all 9 of these will be at your fingertips during any kind of quiz or test. So the double angle for cosine, actually there's 3 different connections between cosine twice of an angle. Okay, there's cosine squared minus sine squared. There's twice the cosine squared minus 1, and 1 minus 2 sine squared. So that one has the most. Sine of a double angle has only 2. Okay, or only 1, sorry. 2 sine u, cosine u. Tan only has 1. This is it here. And there's some half angle formulas as well. So for instance, if I knew 60 degrees, therefore half of 60 degrees would have some special properties, and they would be equal to the plus or minus blah blah blah. So these are here, and we're going to practice those. And same thing for tan. Tan actually has 2 different versions. So let's get to work. Down on the bottom of the page, let's see if I get there. Yep. And if you notice that this setup looks like a version of a double angle formula that is given in number 6. So if you go up and look at number 6, you can see, hey, that looks just like this. In which case, they would mean u to be 18 degrees. And if u is 18 degrees, well, then sine twice u is what they're asking us to find. So twice 18, well, that's just 36. So they're asking what the sine of 36 is. Degrees. All right, simple as that. Moving on to the next one. So you're going to try and spot this one above. All right, if you try to find a double angle formula that looks like this, I think you'll see it in number 3. There it is. Therefore, they intend for u to be 38 degrees. And therefore, on the other side of the equation, they're trying to calculate the cosine of twice 38 degrees, which is just the cosine of 76. Alright, so I think you're catching on to the idea. Just try and find the formula that's being used. Alright, so now we're on a C, and if you take some time and look around, it looks like number 7 to me, right here, matches this, which means that u has to be 117 degrees. So we're looking for tangent of twice that angle. So they're looking for tan of 234 degrees. Okay, so we used a couple of double angle formulas, and I believe this one is going to be a half angle formula. If you're looking for something with a plus or minus symbol in it, well, I think you'll see it in number 5. Okay, so in number 5, in this case, they mean that, or our u value would be 50, and therefore we're trying to figure out the cosine of 50 over 2, which is just cosine of 25 degrees. So again, just finding your formula. I think E is a little different. That looks like number 4. So that's a half angle formula for sine. So we are using our u as 118 degrees. So sine of 118 over 2, and we're really trying to find the sine of 59 degrees. And one more. It looks like we are using a new one here. Looks like number 9. So we're doing tan, a half angle. Our u value is 48 degrees. So we're doing tan 48, cut that in half. Then the tan of 24 is what we're searching for. So you'll have several homework questions tonight or today that look like that, where you're just trying to isolate and figure out which formula to use and use it. All right, let's turn this over. Oh boy, that marker bled through. Sit tight. All right, I have another version, don't worry. Okay. All right, so in this scenario, same thing. We're trying to find out what is the value, or what is our exact value. And you should find this on equation number 2. Okay, we're counting u as 15 in that case. So we're doing cosine of 2 times 15, it's a double angle. And 2 times 15 is 30 degrees, and then you use your knowledge of the unit circle to give the exact value of that radical 3 over 2. So just putting a little twist on it, where at the end you have to tell me what the answer is. All right, so this next one, another double angle formula for sine. You're using u as pi 12ths, working in radians now. So sine of 2 times pi 12ths is just going to reduce to sine of pi 6th, which is half. Remember, pi 6th is 30 degrees. And, oh, I forgot to tell you that that was equation number 6 that I was using. And part C, that looks like equation number 7 on the front. The u value you are using is 2 pi thirds. So we're doing tan of twice this, or tan of 4 pi thirds. And the tan of 4 pi thirds, if you want to get the graphic out from yesterday's work, it may help, is radical 3. All right, so enough of that. Let's move on to a little bit more deep thinking here. And let's set this up. And if we say that the sine of angle A is 8/17, figure out the sine of twice A and cosine twice A. So if we try to draw what's going on here, we call this angle A. And we say the sine is 8/17, that means we are opposite over hypotenuse. Therefore, the adjacent, this is a triple, 8, 15, 17. And again, if you didn't know that, just use Pythagorean. So, the sine of 2A, there was only one formula for that. So that's going to be 2 sine A cosine A. All right, now from this picture, we're able to figure some things out we don't know. They told us the sine A, but in addition, the cosine of A is going to be adjacent 15 over hypotenuse. 15 over 17. All right, so therefore, I'm trying to do 2 times 8 over 17 times 15 over 17. And just carefully use your calculator. I'm going with 240 over 289. And that's that. So we move on. I'm going to split this because there was 2 questions here. I also need to find the cosine of 2a. Now remember, cosine of 2a had 3 different versions. Which one should you use? Whichever one you want. So I'm choosing to use 2 cosine squared a minus 1. If you use another version, you get the same answer. So the cosine was 15 over 17, so 15 over 17 squared minus 1. All right, so that's 2 times 225 over 289. Subtract 1. Very carefully, I believe this will lead us to 161 over 289. So just handling some fractions, and we get our answers. Is that visible? There we go. All right, so moving on to the next ones, I think that we have to do a double angle and a half angle. So, and I'm going to cheat a little bit because I recognize this 5 and this 13. If the cosine is adjacent over hypotenuse, we know that this looks like a triple. I'm feeling like this is a 5, 12, 13 triangle. Therefore, the sine of A automatically has to be 12 over 13. So when they ask us to figure out cosine of 2A, and I choose one of the 3. Why did I choose this one? Who knows? And then we plug in the 5 over 13 squared minus 1. We end up with 2 times 25 over 169. Subtract 1. Very carefully, you're going to end up with a negative 119 over 169. So that's the double angle. And then over here we'll do the half angle. So the cosine of A over 2, and I gotta write this one down because it's used so infrequently, it's hard to remember. Okay, so in this case, when we start plugging numbers in, I have 1 plus, and the cosine of A we figured out over there to be no, we didn't figure it out, they gave it to us, 5 over 13. And we are dividing that by 2. This is a giant square root symbol, sorry. And simplify all your work. You're going to have 13 over 13. You're going to have 18 over 13 on top. divided by 2. And that still is a state change flip if you put a 1 underneath it. All still with a square root symbol. So you end up with the square root of 9 over 13 after you reduce it. Again, your book is not going to give you that answer. They're going to rationalize this. Square root of 9 is 3. Square root of 13, sorry, nobody knows. To rationalize it, you must multiply top and bottom by radical 13. 3 radical 13 over 13. So that's the answer that would most likely be given. All right, so our last question. This is a pretty long video, the longest one so far, is a verification. Now, of course, verifications are the same rules. You're only allowed to work on one side. So I'm going to work on the left side, which seems to be the most difficult looking side. And I'm going to take this numerator instead of sine of 2a. Remember that there's only one version of that. There's 2 sine a cosine a. This denominator, cosine of 2a, has several versions. And that's going to drive you guys crazy because which one should you use? Well, they'll all lead you the right way. The only problem is some take longer than others. I'm using cosine squared a minus sine squared a. All right? So, I want you to remember one thing. This 1 here is also equal to sine squared plus cosine squared. So imagine if I replace this 1. Let's write our numerator. 2 sine a cosine a. And now this 1 becomes sine squared a plus cosine squared a. And I distribute this minus sign. So I got minus cosine squared a plus sine squared a. So the denominator just got real ugly and diagonal. But some canceling is definitely happening. Cancel these cosine squareds. So now you have the numerator 2 sine a cosine a over 2 sine squared a. And here we are with no plus or minus sign, so canceling is in effect. So these 2's out. This sine a with one of these. So all we have left is a cosine a over a sine a. Cosine a over sine a, which equals none other than cotan a, check mark, right hand side. And here we are to the end of the week, 3 days worth of work. You guys are going page 383, 384. You go on numbers 1 through 19, and 23, 32, cross that off. So 32 is out. All right. That's all we have there. That is a pretty long lesson. It's a pretty tough week. This lesson is the toughest probably of all 3. We will get back together on Monday. Thinking about perhaps maybe we can have a meeting. So we'll do either a Zoom or a Google Meet. But I'll let you know Monday morning. All right? Have a nice weekend, everybody.